Alright, the last time I tried to record this, I forgot to turn on my mic, and also it was about a half an hour long of just staring at code. So I don't think that's super helpful. So this time I'm going to try and explain all of it through kind of just a visual diagram, although I might have to open up the code really just to show the config, just for me to remember the names. But this should be a fairly broad overview of what genetics does and kind of how it works. So if you have the artifact enabled, whenever a monster spawns, and I guess we can probably represent a monster with a circle. And so this guy, number size like 3. So let's say this guy's a Lemurian. Ugh, bad L. So let's say this Lemurian spawns. He's going to get something attached to him. He's going to get a little behavior box attached to him. Except it won't be an actual box, it'll be kind of this shape. And this box will have a tracker inside of it that gets a couple of random numbers assigned to it. In this case, they're his genes, but each one of these numbers is mapped to their health, regeneration, movement speed, acceleration, attack damage, attack speed, and armor in order. And then if you have the size modifier enabled, it'll have another one for size. So let's give this guy some numbers. Let's say, actually, let's get another smaller box inside there for his genes. And we'll give this guy some numbers, like 1, 2, 3, 4. Well, you get the idea. He's got some numbers in there. After he spawns, these numbers will be applied directly to him to change his amount of health, armor, so on and so forth. As he goes on living, he might damage the player, he might damage something else. If you've got Artifact of Chaos on, he might damage himself. And every time he damages something, he gets a certain number of points. It's usually equivalent to the amount of damage you do, but there can be a little bit of funny behavior with certain other mods enabled. But let's say he hurts the player for 40 points. So we'll give him 40 points. And then, the player reacts and kills him. He's dead. Get a big old X through him. He's dead. And let's say he was alive for, 17 seconds. Again, the exact numbers don't matter here, but for visualizing this, maybe. He's dead, and he gets 17 seconds of life and 40 points. You divide those, and you get that he had a score of roughly 2.2 whatever. And so that ends up being his score. This number gets pushed into this box, into the tracker, and that's kind of how it goes as far as the body is concerned. And you might be wondering why I started here and not with the overarching thing, and I don't know. Also, I don't paint this. Come on. Okay, I guess I'll just erase it. Is there a way to erase it in white? Oh, it probably is. Yeah. So, I guess I should switch over to the actual architecture of the thing. So as far as the artifact being enabled goes, there are really 3 things it keeps track of. I didn't switch the colors back. So there's this first box, which you know what, we'll make it the full width. This box here is, let's change the font size to like 20. Bigger than that. So this is the masters, or the templates. They're the ones who keep track of the families. You know, if you have it set to the per monster ID mode, it'll keep track of, say, I'm the Lemurian master. I'm going to keep track of all of the Lemurians. If you have it set to general purpose mode, which is the same as, say, turning this tracker per monster ID to false, that puts you in general purpose mode. If you keep this as true, it ignores this setting and then just says, if you're a Lemurian, go to the Lemurian. If you're a beetle, go to the beetle. But if you have this set to false, it kind of just randomly picks. So I guess I could draw that. But before that, I'm going to draw the rest of the boxes. And we'll make a couple of these boxes to kind of show the different families. So each one of these boxes is a family. And then here, down here, is the dead. We will label these as the dead. Family 1, family 2, family 3. So, let's say you have it set to run in general purpose mode, which is default how the mod comes. It comes with this flag set to false, this tracker per monster ID to false. That means you're in general purpose mode. So what it will do is it will create a certain number of masters. You know, we'll call them, you know, master 1, 2, 3. We'll type that into 1, 2, 3. And kind of how this works is every single one of these masters, gets their own family. Okay? Every single one of these gets their own family. Everything that exists in that family belongs to that master. If you're in, here I'll just draw some more circles to show that there's multiple individuals. So let's say, if you're in general purpose mode, this guy might be a Lemurian, this might be a beetle, this might be a stone titan, and this might be a wisp. And that might be kind of all over the place. Let's say a beetle guard. Move that over a bit. Maybe an elder Lemurian can be over here. Let's just put another wisp here, and then one of those mushroom guys. So in general purpose mode, this is kind of how it looks. And when, say, this Lemurian dies, he gets put into the dead. But he still has an arrow. Oh, why can't I? Oh, it's got a box around it. He still has an arrow that points him back here. You know, everyone gets an arrow pointing back to their parent. I'm not going to draw all the arrows because that's not helpful. But this guy has an arrow pointing back to him. In the config, there's a setting here called the tracker update rate. In this case, it's set to 10 seconds. Every 10 seconds, the masters will take a look at the dead, and if anybody is dead that belongs to me, they will learn from them. They will take their stats and how well they did in life and figure out what made them good. If it's health, then this guy will learn that maybe health's a good thing. It's speed, then he'll start learning about speed. Since neither of these guys have any dead bodies to work with, they don't learn anything. Nothing happens. Which isn't a bad thing, it's just there's nothing to work with. So that's kind of how it works in general purpose mode. Oh, and then yes, after they die, and after they've been learned from, they're removed from the that's not what I want to do. They're removed from the dead because they're not useful anymore. They're not useful to the masters as far as learning goes. If you instead have it set to be, if you set this tracker per monster ID to true, these families won't be like numbered. They won't be like family 1, 2, and 3. Instead, let me just do a little bit of cleanup here on this. Actually, let me just get rid of all of this. Oh, that's useful. And so what it does instead is you've got, you know, master 1, 2, 3, except in this case, it's actually master Lemurian, master beetle, master wisp. And in their families, you can only have the Lemurian family, or the beetle family, or the wisp family. And in this case, the only things that can spawn in here are Lemurians, beetles, and wisps. And kind of the same thing for the general purpose. If, say, this beetle dies, he gets put into the dead. But you can be a little bit smart about it this time because he's a beetle. He's only ever going to belong to the beetles. So you can just say, oh, the beetle? Hey, there's a dead beetle. I'm going to learn from him. And the same kind of process goes for that kind of learning. So that's kind of the overlooking process of this whole thing. But as far as actually how it does things without digging into code, since code might not be super useful, but if you want to look at it, there is the repo. It's available. Without digging into code, kind of how the genetic system works is you have, let me draw some shapes. You have this tracker, and you got a couple of things. You got health, you got regen, you've got move speed, you've got acceleration, you've got damage, attack speed, and you've got armor. And then I guess technically you can also have size if you have it enabled. And you can enable that in the config with the setting called enable size modifier. Note, this is buggy. It doesn't really work in multiplayer, so it's kind of a use at your own risk. But the way it works is every single one of these has a number. They start out at 1 because everyone starts out normal. And when a new monster spawns, they roll the dice. Here, I'm just going to draw a really bad looking dice. This is a dice. You can imagine that. So, each one of them goes into the dice, and they come out as, say, 1.1, 1.2, 1.05, 0.8, 0.9, so on and so forth. You can imagine more numbers there. And it's these numbers that get applied to the monster. Now, these are all determined by a upper and lower bound, which you can set in the config as these maximum mutation multiplier. So the way this maximum multiplier works is, so let's say you start with a 1 and you roll the dice. The highest number that that 1 can turn into is a 5. You can only ever be up to 5 times base. Now, what happens if you want to have, it gets unlucky? Well, that 1 can go in and you can come out with a 0.2. You know, it's 1/5 as good. However, you can't just do that in one step. You can't go from 1 to 5 instantly. Instead, there's a kind of a safety net here, this deviation percent, which is by default set to 0.1 or 10%. So you might notice how here I've got this 1.2. If you had a 1 going in, 10% different is 1.1. This 1.2 can't happen. And this 0.8 also can't happen because those are not reasonable mutations. So instead, those would probably be corrected and become like, it might become 1.1, and this one might roll again and become 0.92 or something like that. Now, when the monster dies, its score, which let's say it has a score of, let's see it at 25. The number doesn't really matter here. But this score here gets compared to every other version of that monster that is currently sitting in the dead pool. That's kind of funny. And they get compared, and the master that's keeping track of them, the big template guy that used to be like right up here, he compares them all and takes the weighted average. This is how it learns. It takes a weighted average. If you get 0 points, you just get ignored. If you get a ton of points and everybody else doesn't really do that well, you're going to really strongly become the template. It's going to learn a lot from you. Once that happens, once the template has learned from you, you die, and these ones kind of go away. This is kind of the template here. I should have mentioned that earlier. Also, all these arrows are kind of annoying. So let's start this over. Let's not start it over. Here's the template, and here's the instance. So say it learned from that guy, and now health is 1.1 and 1.1 and 0.9 and so on and so forth. Now these values, when a new one spawns, get rolled, and they can come out and say, this 1.1 can turn into 1.21. It can get better. It might try to do things funny, and it might try to make it just normal again. It might try to make it worse. Who knows? It's kind of a chaotic system, but it's always going to be a very small step in either direction. Although it could potentially go in as a 1 and come out as a 1. That's very unlikely, but it is possible. And these numbers are kind of all controlled by these tracker settings. There are a couple of settings in here that are not things I can like draw. These being the optional settings, which just makes it apply to neutral characters and to minions. So like engineer turrets or drones, you can turn that on and it'll apply to them. And then there's some logging here. If you happen to run into a bug, you can try turning some of these on. I should warn though that this spawn logging does tend to create a lot of lines in your log. It's not a ton, like it's not a crazy amount, but in say 2 hours you might get a couple thousand lines just from this thing. Not errors, just saying hey, something spawned. This accidental death logging, I'm going to say leave that on true, just in case you find the negative infinity health bug. It's nice to have that there. So that kind of leaves us with the last two settings. This product and the step size. I'm going to tell you right now, leave the step size relatively small. Really all this does is change how aggressive the balance system is at its penalties. So let's say, well, I can't really explain that without explaining this. So the maximum mutation product. This is weird. This is a weird math thing. So I'm going to try and explain it with actually a graphing calculator here that I have here. So I'm just using this because it's got the nice sliding bars. What you have here is your 7 stats. I just have them A, B, C, D, F, G, H. You can't use E because that's an actual number. So let's say you come in and everything's set to base. And randomly, or over time, the health starts to go up a little bit. The acceleration, or I don't know why that isn't, but let's say some of these stats go up a little bit. And you reach a number like 153. That's really strong compared to base, because everything is at least twice as strong. Except for these guys, but this guy's almost 3 times as strong. So what this system does is that using this step, it will try to bring these down randomly. So this 2 will become a 1.9. Well, that didn't work. It's still higher than 10. Let's bring this guy down a little bit. Nope, still too high. Let's bring this guy down a lot. Still way too high. Well, let's bring this guy down some more, and nope, still way too high. What happens if we move him down smaller than normal? Well, that's technically within the bounds, and that's pretty close to 10. So it might pick one stat to just really aggressively penalize. Or it might just make things just a little bit stronger. Like this guy. Everything's higher than average except for, this stat. But it's still close to 10. If you want to make it so that everything can be maxed out, you can do something really kind of easy here and just take whatever your maximum is. So in this case, this 5 here. You can do 5, and you can multiply it to or you can take it to the 7th. So let's say you want it to make it so that everything can be absolutely maxed out. You'd have to set this number to like 78,000, which you can see if you bring everything up to 5, the number gets really big, really fast. Yeah, there it is, 78,000. I find, and we can get rid of that, I find that 10 is a fairly reasonable number, because it allows it to max out some of the stats, but at the cost of having to minimize some of the others. It gives it kind of a min-max thing. Note that if you set this number to 1, it will try to make things perfectly balanced. If something's a 5, something has to be 1/5. If something's 2, something has to be 1/2. So setting this higher than 1 makes it so that they can be kind of a bit better than average. Setting it exactly to 1 makes it perfectly balanced. And so without digging into the code, that's kind of all I can do to explain genetics. If you're curious more about this, there is the repo. You can read through the code yourself. I have some comments in there. It's not great. It's just enough for me to be able to understand it. Or, I guess if the demand is high enough, I could probably do a full code walkthrough eventually. But not today, because this is just supposed to be a basic explanation. And so, there it is. think I'll probably leave comments on for this video, just in case you have any, like, real quick questions. Might turn it into a little FAQ thing. But yeah, that's kind of genetics in a nutshell. So, yeah, I don't know how to end videos. I'm just gonna end it.